So in this lesson, we'll learn how to do transversals. So to begin with, what is a transversal? So you've got parallel lines, and any line that intersects two parallel lines. This line is called the transversal. So it forms a number of angles, and we'll need to go through a few basics to determine the angles. So let's mark the angles. A, B, C, D, E, F, G, H. So let's do a few tricks to these. And we've got to use our basic concepts that we've learned from earlier. So we know angles on a straight line. Add up to 180 degrees. So let's say B and A in the diagram. So A plus B is 180. If you know one value, you can determine the other one. Similarly, C plus D is 180. Then we know that intersecting lines, you can prove using this idea that A is equal to C and B is equal to D. You can prove it. Because let's work it through the circle. So we'll move in this direction, okay, throughout the circle. So we know A plus B is 180. Right? So let's define B in terms of A. So is this what we get? So we've reached this part, right? Then we know that B plus C is 180 because that's another straight line. Look at it this way. So you've got your straight line. I'll draw it in black. Sorry. And we've got this, like this. So our angles are B and C. Right? So we know B plus C is 180. But we also know B is 180 minus A. So let's plug that in. 180 minus A plus C is equal to 180. Now as complex as this may seem, if you have two equal sides, two equal values on each side, they actually end up to solve as 0. Because if I subtract 180 from both sides, and I add A to both sides, this cancels, so C is equal to A. So we've proved algebraically that these two angles are equal. So instead of me writing C, I'll write A. So we've found these two to be the same. Now similarly, using the same argument, you can prove that B is equal to D, right? So A plus D is equal to, so now you would get these pair of equations from the bottom and from the top. So this is equal, this is equal. So these two have to be equal. So we know this is B, right? Similarly, we can prove, now the lower section is the same as the upper section. So instead of H, I can write an E. And instead of G, I can write F. Because they're equal. So this brings us to the property that we discussed earlier about vertical angles. So vertical angles intersect like this, and opposite angles are equal. So this angle is equal to this, and this angle is equal to this. You'll see this property corroborated by, we're back on this diagram, right? So we got this part. Now we've got to prove what is the relationship between B, E, A, B, E, and F, if we can, right? So let's see what happens here. So if you look at the diagram at the top and you cut it from there and you bring it and you replace it or overlap it on the second section on EF and FE, do you see the same shape at the bottom? Something like over here. So where is vertical angles applied? So is the DOT just saying that angle R is equal to angle R? Probably. Just a mathematical code on the road. Oh, that rhymes. Mathematical code. On the road. So we see the same shape. Another thing you might see, I think it's in a box or maybe a triangle, I don't remember. But again, you've got yellow in the background. I think it's a triangle. I'm not sure, but I might be wrong. But I just want to show you one. You might have seen, sorry, something like this. So these are all parallel lines. You may have even seen this. So you may have seen this on your road. And the median, even though these are white. So imagine them to be white. These are all parallel lines. And then your parking lot, where you'll see parallel lines like this for spaces to park. Okay? If we see this shape over here, then that tells us a lot about the angles. That means these two should be equal then. And then these two should be equal, right? So this brings us to four important properties, and one easy way to remember it is by using this word physics, but spelling it as F, Z, C, and X. Physics. Whenever you think parallel lines and angles and values, think physics. So I'll show you the four angles that are required. So F, the angle over here is always equal to the angle over here. These are called corresponding angles. Then Z. These are called alternate angles. Some books might show it alternate interior angles, but when you see the word alternate, that's what you want to go for. So alternate angles. They form a Z. Again, this angle, maybe use another letter for it. B, B. Then you have C. These are called interior angles. So this would be A and maybe C. Here they add up to 180. This is the only property where you've got to do some algebra, right? And the last one is intersecting, which is the railroad sign. You can remember it that way.